Hello everybody, I'm Emre Koçyiğit. This is the second video of Feature Engineering Guide video series. In the first video, I explained the feature engineering position in the machine learning pipeline. Remember that the feature engineering techniques can enhance the data quality, and data quality is of course quite critical in machine learning performance, in machine learning models. And also briefly, I explained the feature engineering pipeline, feature understanding, feature structuring, feature optimizing, and the feature evaluation parts. If you are interested in these fields, in these stages, you can watch the previous video. Also, I explained we have 5 feature engineering techniques after explaining these steps. These are feature improvement, feature construction, feature selection, feature extraction, and the feature learning. In the first video, I also explained the feature improvement techniques. For example, when you have missing values, how can you improve your features? How can you deal with these missing values? Imputing is one technique. And I also shared some code examples to demonstrate the practical implementation of each technique. Okay. Here, for example, we applied KNN imputer, or another one under the feature improvement is normalization. So I mentioned that we have different scalars under the scikit-learn preprocessing, and for example we have standard scalar, min-max scalar, and robust scalar. In different problems you will need to use scalars, and I showed an example here. And the last part of the feature improvement was removing outliers. We will have some outliers. How can we detect them? How can we deal with them? So I provided some examples here also. And now in this video series I will explain the feature construction, our second technique, second feature engineering technique. In the feature improvement, we didn't change the shape of the feature set. We have, for example, 10 dimensions. After the feature improvement, we will still have 10 dimensions. But in the feature construction, we can add a new feature, or we can convert our existing feature, and we can change the dimensions, or we can change the interpretability of that specific column. For example, we can have height as a feature, and additionally you can add weight column, or you can add BMI, body mass index column, by using height and weight. Both of these scenarios are feature construction examples. Another one, you can have a salary column, and instead of having these numerical values, you can define some categories, and you can define a new feature, salary level, and they can be high, medium level. And as you see here, the interpretability of the feature is now different. So that is the huge difference between the feature improvement and the feature construction. I will show some examples of feature construction. First of all, I'm using the same notebook, so let's remember our data frame. We have different columns. Here you can see these are all features for us. And if I check the statistical information of this data frame, you can see the mean value, the standard deviation, minimum maximum value. And for example, I can say that for the BMI feature, based on the minimum and the maximum values, I can define a threshold, and I can create a new categorical feature. So I can apply feature construction techniques. And for example, I can define two thresholds, threshold 1 and threshold 2, so based on the statistical information. And then with this part, I can use the BMI. I can simply say that if the BMI value of that sample is higher than 0.04, threshold 1, then the categorical value of that sample will be high. If the value of BMI is lower than minus 0.04 in our second threshold, then the categorical value will be low. Between these thresholds, the values will be normal. So simply with this command, I can define a new categorical feature, BMI category, and I can say that. So this is an example of feature construction. And if I just printed the first 10 rows, you can see these are existing features, and at the end I have BMI category. So for the first one, it is higher than 0.04 for threshold. So the category is high. The second one is lower than minus 0.04, so it is low. You can see we have three different categories. So this is a simple example of feature construction. And in the feature construction part, you can completely remove this BMI, or you can keep both of them and you can see that which one is more important for your model. Let's look at second example. I will use another data set here, Fetch California Housing. So the data set is about houses and their prices, their values. So we will try to predict the prices. So this is a simple regression problem. First of all, by using this Fetch California Housing, we will obtain our data. And if you look at the target names, the house values are our target names, and the feature names, we have different features like age or number of rooms, bedrooms, or latitude, longitude for information. So I can create a data frame, so df3, so data of this data and the feature names as column names. Okay. Here I'm not specifying the target column because I don't need, but of course you can also add the target column here. If I check the first 5 rows, you can see the features and the values are all numerical, but we can simply check the information and we can see that we have 20,640 entries. We don't have any missing values. All of them are numerical, they're floats, and we have in total 8 columns. If you look at also some statistical information, we can check that their minimum value and maximum value, so they are not scaled. We can see that they are not scaled. Also, of course, for more advanced exploratory data analysis, you can check their mean value, standard deviation, and you can check the distribution to check if there is any anomaly or potential outlier. But now the focus is just understanding roughly the data. Okay, so based on our information, we can say that maybe we learned that certain year is critical in house prices because of a legal regulation. So since the regulation forces to increase the quality of the building material, that can be important. So from our domain knowledge, we can say that age is general important feature, but also certain ages can be more important because let's assume that this deadline is 2000. If that house is older than 23 years old, that means that is built according to older regulations, right? But if it is 15 years old, yes, they are new, but also it represents the quality of the material. So that is another issue. So we can simply say that check the house age, and if the age is less than 23, then it will be 1, otherwise 0. So if it is young or not, okay, or if it is before the regulation or after the regulation. 1 means after the regulation because the age is less than 23. Okay? So let's create this column, and at the end you can see here the age is 41, so it's older than 23, so 0, but 21, so 1, and others are 52, therefore they are 0. This is another example. And I will give you another example for the feature construction. So let's assume that we just plotted the longitude and latitude in a scatter plot. So there are houses in a specific region, right? And based on this longitude and latitude, from my domain knowledge, maybe from another studies, benchmarking studies, maybe from the literature review, I don't know. But let's assume that from domain knowledge, we know that certain regions can be more valuable because of their location, because maybe they are close to airport, maybe they are close to another important city, maybe a port, I don't know. But let's assume that we have certain 3 regions. So I can also apply feature construction technique to have a new feature to represent these regions. Okay. So I can simply define this categorized region, and based on the information I can check first longitude. If it is bigger than minus 108, so I will check this part. Okay, if that part will will be one region, so region 1. If it is in the west of this longitude, then I will check also the latitude, and if it is higher than 38, it will be zone 3, but if it is lower than 38, then the region will be 2. Okay, so simply this part is region 1, this part is region 2, and this part is region 3. Okay, so I can use apply method of pandas, and I can give my function here, okay, with axis 1. Then when I check the first rows, here you can see now I have a new column as region, and based on the latitude and longitude information, it will be 1, 2, or 3. Here you can see now I have 3. In the first rows I have 2, based on this latitude and longitude information. These are all different examples. Let's plot it, demonstrate the region information with latitude and longitude. So here you can see now this is region 3, region 2, and region 1. Okay, that's all about feature construction. In the next part, in the next video, I will elaborate the feature selection, another feature engineering technique. Simply, feature selection is a technique to select the best subset of feature sets. Of course, it will affect the dimensions because we will reduce the features, then we will reduce the dimensions. But the objective is increasing the performance while decreasing the cost. For more details, you can check the next video. Thank you for watching.